Chapter 7, Engine Powertrain Components. You will be able to identify engine powertrain components, define the role of piston assembly in the engine powertrain, identify trunk and articulating pistons, describe the monosteel pistons and identify the reasons they're becoming pistons of choice by engine OEMs, and outline the advantages of the Mexican hat open combustion and modern direct injected low emission diesel engines. You will know how piston rings act to lubricate the cylinder and seal the cylinder combustion pressure, identify some commonly used diesel engine piston rings, and classify piston wrist pins by types. The role of connecting rods outline the stresses to which they're subjected, common crankshaft throw arrangements and match to the appropriate cylinder block configurations, the forces crankshafts are subjected to in normal operation, describe the materials and manufacturing processes, surface hardening, and typical heavy-duty crankshafts. Outline the cause of abnormal bending and torsional stresses crankshafts are subjected to. Identify some typical crankshaft failures and their causes. Evaluate crankshaft condition visually by precision measurement and electromagnetic flux inspection, that's crack inspection, and describe some common crankshaft reconditioning practices. And you'll know the procedures for in-chassis rod and main bearing rollover, and measure friction bearing clearances using Plastigauge. Define the term hydrodynamic suspension, outline the role of harmonic balancer and flywheel assemblies, and the principles of operation of a viscous type harmonic balancer. You're going to be doing piston removal and replacement, and the flywheel will outline the steps to recondition a flat or pot type heavy duty flywheel. Okay, this chapter addresses a group of engine components responsible for transmitting the gas pressures developed by the engine cylinders to the engine power takeoff mechanism, usually a flywheel. Powertrain components: piston rings, wrist pins, connecting rods, crankshafts, friction bearings, flywheel, and vibration dampeners. They are all part of the powertrain, also known as the rotating assembly. Piston assembly. By definition, a piston is a circular plug, seals the engine cylinder bore and reciprocates with it. The piston is subjected to gas pressures within the cylinder. And here's a cross-section of a piston. We have the combustion bowl on the left valve pocket. The ringland area where the rings are, we're showing the compression rings at the top, scraper rings, groove rectangular style, oil control rings, a lubrication channel where oil will flow, and snap ring grooves on the piston pin boss. On this side, we're showing the Mexican hat. It's a type of style. We have the crater for the recess that allows the combustion to occur more effectively based on the injection. The crown, which is the very top of the piston leading edge. The ring headland, the ringlands and the ring belt, a monotherm relief neck, and monotherm guide skirt. There is more mass of material on the piston ring boss side than there is on the piston guide skirt side. Two basic types of designs in current commercial diesel engines are trunk style and articulating style. Trunk pistons until the 1990s were all aluminum. They contain used today in light-duty applications in medium-duty trucks. Forged steel pistons are the style that are used in medium and heavy-duty commercial engines. And composite steel trunk pistons have a variation of forged steel trunk, and the crown and skirt section of the piston are manufactured separately. We have them in the shop now in our 12-liter Cummins Westport natural gas engine. Here's a typical trunk piston defined here. We have what's called a nye resist or nickel resist ring insert in the ring groove to make it more stable in heat. We have a second, third, and fourth land for rings. We have the thrust face, which is on the right-hand side, based on the direction of the rotation of the engine. So from the front, Your thrust face is going to be facing the right-hand side of the engine. We have different types of compression rings here based on wedge shape and keystone shape. Well, we'll get into them a little bit later in depth, and different types of U and coil type oil control rings. These rings are very important in keeping the engine running well. Advantage of aluminum is lightweight, cooler crown temperatures, and quieter. The disadvantage is that aluminum will melt at a much lower temperature than forged steel. So if there's an overheat condition or a cylinder being torched by too much fuel, aluminum pistons will fail first. Okay, steel trunk pistons are able to reduce the headland volume because we're able to put the top ring closer to the combustion chamber. The thermal expansion is simply how the piston materials respond to heat. This is important based on the correct fueling with the load and how the heat transfer occurs in the piston. Longevity, alloyed forged steel coated with phosphate provides much longer service life than your typical aluminum trunk piston. Monotherm made by Mahle or monosteel made by Federal Mogul are light in weight as aluminum but have the strength to sustain increasingly high cylinder pressures of modern diesel engines. Now these are well over 3,000 psi. Mahle version is the most popular type of piston. It's a forging that has minimal amount of machining processes, and they have a separate skirt here. Does not have to be supported because of the weight characteristics. Also, the pin boss is larger, and it allows a larger piston pin to be utilized for longevity. Composite steel trunk pistons, a variation of forged steel type piston that is crown and skirt are sectioned, so it's two pieces. They're screwed together using proprietary process, and the crown section is manufactured of high-temp steel and then screwed to the steel skirt assembly. Two types of articulating pistons. Crosshead pistons. There's a semi-floating piston pin bolted to the connecting rod. So it's going to float on the end of the pin, but the rod and the pin connection is going to be stationary. Fully articulating pistons have a full floating arrangement that you can see that the pin floats on the connecting rod end, but it also floats in the piston boss itself. The disadvantages of articulated pistons over the aluminum is significantly increased weight and increases the tensional loading on the powertrain. They require the use of beefed up or reinforced engine cylinder block and other powertrain components, especially the connecting rod and the crankshaft. For advantages, we have greater longevity, reduced piston slap because of the geometry, more durable crown assembly. Now that's a combination of heat transfer, and lubrication, and reduced headland volume. The less headland volume we have, the more potential we have for a higher cylinder pressure. High turbulence. Today's engines produce much higher injection pressures that result in smaller droplets of fuel. So the turbulence is no longer as required. High turbulence can actually be a disadvantage, causing clusters of fuel droplets to be thrown around the primary flame front. We'll get into that a little bit deeper into when we do the fueling side of this class. Quiescent dynamics is less swirl and turbulence. Okay, your Mexican hat, we have those. We're going to show you those in class. The injector point tip is located right over the top of the hat. OEMs frequently use Mexican hat pistons because diesel engine fuel droplets can be directed into the crater, and it creates some swirl, and it lowers the risk of burnout scorching of the piston crown. Man type or M type are used in older trunk style pistons, consist of spherical recessed bowl located directly under the injector. Depending on the depth, the manned combustion chamber generally produces high turbulence but is more vulnerable to localized burnout in the bowl. The M-type piston crown is not common today. You will see that in older engines in heavy equipment, and if you have to replace one cylinder piston, you're probably best to change out all six. Combustion chamber design: dished, piston crown slightly concave to almost flat. Design produces low turbulence when compared to previous designs. You'll see this in current small bore and older IDI diesels that have cylinder heads located with a pre-combustion chamber. That's a chamber that typically houses what's known as a glow plug. Oiling. Piston cooling is done by oiling primarily. We have they call this a shaker. You're going to have a hole that is machined into the connecting rod, and that allows oil to travel up into the up to the piston pin boss, but also into a chamber inside the piston. Circulated oil, delivered through connecting rod rifling through the wrist pin, circulates through a series of grooves machined into the underside of the piston. Then it drains back into the crankshaft. But a stationary oil jet spray mounted on the bottom of the crankcase feeds lubricating oil directly underside of the piston, often to a circular cooling gallery. These oil spray jets have to be aimed precisely to the bottom of the piston, and that is based on the OEM specifications. A misaligned spray jet will destroy a piston, an engine, by torching the piston it's supposed to be cooling. So if the spray jet window, and pay attention to the making contact with the fuel jet when you're installing your assemblies. Because aluminum melts at a much lower temperature than steel, cooling of aluminum pistons is more critical than with forged steel or articulating. However, a misaimed piston cooling jet will cause rapid failure in newer engines, regardless of the material that the piston is made of. Okay, 3 functions of the rings. We need to seal the combustion chamber. We have to hold high pressure and when we're building the compression, and on the power stroke we have to hold a high cylinder pressure. Lubrication. We have to have a film of engine oil coating the cylinder walls so that the assembly is well lubricated. And the rings also provide heat transfer. The top ring especially has high temperatures, and we need to have the correct amount of oil on the engine cylinder so that the rings can clear the oil and apply the oil as the strokes occur. Ring action sealing. Pressure forces the ring downward into the land, so the ring is being pressed down into the land or the piston ring groove, it's also called. Forcing the ring into the land enables cylinder pressure to get behind the ring. When cylinder pressure gets behind the ring and it's the groove wall, it gets driven outward into the cylinder wall, creating the seal. This happens instantaneously. Ring action lubrication. Oil control rings designed to maintain a specific managed film of oil on the cylinder wall. On the downstroke, when not loaded under pressure, lubricating oil is forced into the lower part of the ring groove while the ring is connecting the upper ledge of the land. When the piston changes direction to travel upward, the ring is forced into the lower end of the land, allowing the lube oil to pass around the ring to be applied to the line of wall. This has to occur perfectly, or the cylinder could have major malfunction. Different types of rings. Keystone rings are popular: barrel-faced, rectangular, inside bevel, and taper face. Different types of straight, angled, and step joints or scarfs are used. They are engineered precisely to do a combination of sealing and lubrication. Most rings have an upside. You may not be able to see, but some rings are marked by the OEM with a dot, and if you see a dot on a ring, it's usually close to the piston ring gap. You'll see a dot, and the dot always faces up. Piston wrist pins. The wrist pin or the piston pin connected to the assembly with the connecting rod small end. Full floating pins are fitted into both the rod eye and the piston boss with minimal clearance. Requires means of preventing the pin from exiting the boss. Contacting the cylinder wall. Snap rings and plugs are common. When installing internal snap rings used by most OEMs, it's important to observe the installation instructions, and where the gap of the snap ring has to face is generally down. Connecting rod. The small end is the wrist pin bore. The bushing, we have a bushing that acts like a wear sleeve. It's typically a bronze alloy, and it will wear and be able to be replaced, and the rod can be rebuilt in a specialty shop. The piston, the crankshaft bore, with the cap, it has a two-piece friction bearing in there, and bolts. These are typically, the bolts have a torque to yield setting, and we'll get into that a bit later when we do engine assembly. Connecting rods transmit the force developed in the cylinder. The end of the connecting rod that links to the wrist pin is known as either the rod eye or the small end, while the end that links to the crankshaft throw is known as the big end. Both the rod end and the big ends have bearing surfaces. Connecting rod loading, we have compression during the compression and power strokes, and we have tensional loading or stretching. And at the bottom, at top dead center to bottom dead center. This occurs frequently per second when the engine is run at normal speeds. Engine overspeed will cause a connecting rod failure. Typical crankshaft throws in our inline 6, which is our common heavy truck engine. We have the companion cylinders again, and they are each geometrically defined by their position in the crankshaft. There is a oil passageway called a journal oil hole, or it's also known as rifling. That hole is designed to transmit oil. We have oil galleries that are in the block that connect to the main bearing surfaces. So the main bearing surfaces will be transmitting oil, pushing oil through to the mains and the connecting rod. So all of the journals on this crankshaft are rifled or oil gallery together, so we have a film of oil on every critical surface in this crankshaft. Hydrodynamic suspension. This is a key necessary ingredient in the life of the crankshaft and also camshafts and other assemblies. They essentially, the hardened material, the journal of the crankshaft, is going to float on a film of oil so that there's actually no metal to metal contact between the bearing surface and the crankshaft hardened journal. That is a very critical specification that we have to pay attention to. We're going to measure that with plastic gauge. Crankshaft forces, there's a dynamic balancing in manufacturing. The OEMs will typically balance the crankshaft approximately double of its operating RPM. So if a crankshaft has a wide open throttle of, let's say, 2100, the crankshaft is typically balanced over 4000 RPM. Okay, cranks and bearings. The crankshafts are made of forged steel, but there's special cast iron alloys are used. Cranks are tempered, they're heat treated to provide a tough core with enough flexible characteristics to withstand the bending and a torsional load that they're subjected to during normal operation. We have flame hardening, nitriding, and induction hardening. Today, our OEs are using induction hardening, where they lower a electrode onto a crankshaft surface that has to be hardened. You will see some bluing or heat effect on some crankshaft journals and balancing lobes where the electrical induction hardening takes place. That is typically what's used today in heavy-duty diesel engines. Bending forces occur between supporting main journals in each power stroke. It's normal that bending takes place during the crankshaft when it has maximum load on it. And those torsional forces are actually bending the entire crankshaft. They stretch the crankshaft with twisting and vibrations. It's pretty straightforward, and it balances out with the oscillations of the engine running at a variety of speeds. Failures: if the crank is bent, you're going to have a failure at the balancing lobes and the journals for the connecting rod. Torsional failures occur from engines being oversped or running away, or vibration damper going out of balance, so crankshafts can actually break. Also, spun bearings. Bearings are held together with bearing spread and bearing crush. And if the bearings turn inside the journal, where the journal and the main bearing cap is, if the bearings turn, they lose their lubrication and properties and will have failure at that journal and subsequently the entire engine. Okay, crankshaft reconditioning. There's specialty shops that are out there that can recondition crankshafts depending upon what's available in an overgrind situation. Also, flamed metal can be applied to surfaces and grinding them down to original size. That is done in specialty crankshafts, and in very large off-highway it's done on site in maritime and heavy equipment and mining. They use chroming on the surface, and they also arc welding build up followed by grinding to the original size. So there's a few processes that are done to bring the crankshaft into the workable diameter that's necessary to rebuild the engine. Out of round, we're showing between 1 and 2 thousandths is maximum. Taper, 1.5 thousandths, so that's 1,000 and 5/10 thousandths. Bend in the crankshaft is done by using precision V-blocks on a surface plate, and there are different specifications based on crankshaft materials, length, and engine design. The plastic gauge. We will be demonstrating and utilizing plastic gauge in crankshaft and connecting rod locations. Essentially, we have a gap or a interference fit between our components, and the components that have a gap is going to be where we put the plastic gauge. We're going to clean the surface between the bearing and the journal. We're going to put in this thin piece of plastic. We're going to assemble it to about 2/3 of the specified torque. The bearing and the hardened surface will crush the plastic gauge, and we're going to be able to read it on the packaging, and the thickness of the crush will give us the exact dimension of our clearance between our hardened journal and our bearing material. This is critical, and it's something that we have to do on all main and connecting rod journal surfaces. Bearing rollover. Bearings have a what's called a tang, and bearings have a few layers here, and the tang has a recessed surface that's machined as an undercut into the connecting rod or the main bearing cap. So one half of it's cast into the block for the main bearings, and the other half is cast into the bearing cap. And if you examine it, you'll be able to see that this particular detail will line up, and we'll be able to see that more accurately as we examine bearings, connecting rods, and main bearing caps. Here we have what's called bearing spread. The bearing has to be slightly wider than the bore that it's fitting into. When it's pressed into the bore, it's going to have a small amount of bearing material that extends past the flat of the housing, or it may also be the flat of the bearing cap in the case of connecting rods and crankshafts. When we assemble the two pieces, the crush and the bearing spread become critical in holding the bearing into the housing and the cap. Okay, we're going to get into vibration dampers. Vibration dampeners essentially take the oscillations or the harmonics. They're also called harmonic balancers, and they smooth out the harmonics that are in the rotating assembly. Everything on Earth has some type of harmonic and oscillating energy. Crankshafts, when they're subjected to the loads that they experience in the heavy truck and heavy equipment side, have a tremendous amount of oscillations and harmonics that have to be dampened. So what it does is it actually smooths out the sound waves, which are the harmonics. If you have a damaged vibration damper, you can have a broken crankshaft as a result. This is a viscous damper that essentially contains silicone gel. Okay, if you see any distortion in a harmonic balancer or a viscous damper, A failed damper will cause crankshaft failure. So if you can see visual distortion, or you can check it with a dial indicator, but any distortion at all can cause crankshaft failure pretty quickly. Flywheels, they store kinetic energy and smooth out the power pulses of the engine. They also have a ring gear on it, allows our starter to have a place to crank. And in the case of recently in our shop, we're using boring tools that pair a port in the flywheel housing to the flywheel ring gear, which allow us to bar it over. So all of that is coming from our flywheel. Okay, this is a sectional view. This one has media gel in it, and it has a inertia ring. Okay, showing engine side is usually marked. Okay, you have warpage. You look for heat. Heat effect will usually discolor metal. It starts off as blue and it'll go from brown to black in severe cases. Scoring or scratching of a surface. Okay, if there's a alignment problem, it's going to show up in the holes that are in the crankshaft mounting. And then axle and radial run out using dial indicators and straight edges. We did that in drive, and we'll do it again here in diesel engine assembly. Recondition the flywheel. Flywheels are generally surfaced in a specialty shop today. Some shops have the ability to do the clutch face with a wet grinding process in a fixture. I've seen shops do that, and it's a relatively simple procedure, and it surfaces the flywheel so that the clutch will have a good life. Ring gears are generally done in specialty shops. It's really not done in regular service shops, and you basically submit the flywheel as a core, and they will do the precision welding that's necessary to recondition the flywheel so it can go back into service. Okay, for the purpose of this particular section, we want to make sure that we understand the differences and what has evolved and what components are out there and still may be out there in medium and heavy duty engines. We're not seeing a lot of aluminum when we get to heavy duty, but medium duty will still have those. We'll see that companies like MAHL, and I have more material on MAHL, they are one of the MAHL and Federal Mogul are the major manufacturers of piston. I believe MAHL has more market share. The difference between steel trunk, Mexican hat, how important oil and oil spray jets are in our heavy truck engines, and piston rings. Piston rings have such a critical contribution to cylinder pressure and lubrication, and we're going to be showing you that as we remove some rings and install them and understand how the rings are critical to the life of the engine and the holding the cylinder pressures. We understand the gases, the keystone ring design, which is common for your top compression ring. Now keep in mind your top compression ring is the hottest of the two or three based on the configuration, so it has the most amount of thermal stresses on it. Oil control rings applying the correct film of oil, and full floating wrist pins, which are the most common in our highway truck engines. Okay, we have the snap rings for that. We're not going to really see much in Detroit diesel two-stroke engines. They've been illegal since 1991, but they still like to, let us know that they are still out there in industrial applications. They are being reduced as environmental legislation becomes more proactive in the work site. Connecting rods have both compressional and tensional loads on them, so we're going to have to pay attention and examine the connecting rods thoroughly for cracks. That we're going to do with a magnetic particle. Cranks are designed to withstand the constant bending and torsional stresses. Okay, we have essentially induction hardened crankshafts. That's where the electrical component comes down to the crankshaft, puts a certain amount of AC voltage and a certain period of time into that area between the two assemblies that drop down, and they will put enough heat into the component to allow it to have the correct temper. Okay. Crankshafts may or may not be approved for reconditioning. Cummins went through some concerns there. We'll go over that in class. And how friction bearings in crank and main crank for crankshaft throw, which is connecting rod, and main journals are retained by crush, and also the tang, and how vibration dampeners consist of a drive member, medium, and inertia ring. Our viscous type dampers, that's the most common in today's trucks. We're going to take a look at those and how we can diagnose a visual inspection of those, and how the flywheel works to smooth out the power pulses on engines, and how the SAE, Society of Automotive Engineers, characterizes flywheels by style and shape.